The Impact of Music Genres on Water Structures and Human DNA, a comparative analysis of classical and modern music frequencies. Introduction and background. Research rationale. The study of how music influences the physical world and human health is a burgeoning field of interest. Particularly, the impact of various music genres on water crystallization and human DNA has garnered attention due to its potential implications for health and well-being. This research paper aims to dissect and understand how different music types, specifically classical versus modern genres such as rock, heavy metal, and pop, affect water's molecular structure and consequently human DNA. Historical overview. Historically, the concept that sound frequencies can influence water and biological systems has roots in ancient philosophies and practices. Modern science has begun to explore these claims with a more empirical approach, especially following Dr. Masaru Emoto's pioneering work on water crystal formation in response to different sound stimuli. His findings suggest that water exposed to harmonious sounds forms aesthetically pleasing crystals, whereas dissonant sounds result in fragmented and irregular formations. This sets the groundwork for investigating the broader implications on human DNA and health. Theoretical framework. The theoretical underpinnings of this research rest on the principles of cymatics, the study of visible sound and vibration, and epigenetics, which examines how external factors can influence DNA expression. Classical music, characterized by its complex harmonies and frequencies, is posited to enhance DNA repair and promote healing. Conversely, genres like rock, heavy metal, and pop often feature rapid tempos and dissonant harmonies, which are theorized to produce lower vibrational states that could be detrimental to DNA structure and function. Objective. This paper aims to provide a comprehensive analysis of existing research, conduct comparative studies, and present new insights into how different music genres affect water structures and human DNA. We hypothesize that classical music will show a positive correlation with water's structural health and DNA repair, while modern genres might demonstrate negative effects. Significance. Understanding the relationship between music, water, and DNA is paramount for multiple disciplines, including healthcare, music therapy, and environmental studies. By elucidating the specific impacts of different musical genres, this research could inform therapeutic practices, improve well-being, and contribute to the broader discourse on environmental and personal health. Comparative studies and methodological approaches. Comparative analysis of music genres. Building upon the theoretical framework, we conduct a comparative analysis of classical music, e.g. compositions by Bach, Mozart, and Beethoven, against modern genres like rock, heavy metal, and pop. This involves examining the frequency range, tempo, rhythm, and harmonic structures of each genre and their respective influences on water crystallization patterns and DNA molecules. Studies incorporate spectrographic analysis to visualize the impact of these sound frequencies on water and, by extension, cellular structures. Experimental design. A series of controlled laboratory experiments are devised to observe the effects of music on water and DNA. Water samples are exposed to different music genres for varied durations and under consistent environmental conditions. Post-exposure, the water samples undergo crystallography to detect structural changes. Simultaneously, in vitro experiments with human DNA strands are conducted to observe potential changes in molecular configuration, integrity, and repair rates under different musical stimuli. Data collection and analysis. Quantitative data from the crystallography and DNA analyses are collected. This includes measurements of crystal symmetry, size, and formation rate for water, alongside DNA strand integrity, repair frequency, and structural alterations. Advanced statistical methods are employed to ascertain correlations with a keen focus on distinguishing the complex impacts of different music frequencies, tempos, and patterns. Theoretical integration. The study integrates principles from physics, biology, and musicology to interpret the data. Theories from quantum physics are considered to understand how vibrational frequencies might resonate with molecular structures in water and DNA. From a biological perspective, the potential mechanisms underlying the observed effects on DNA repair and health are explored, including stress response pathways and epigenetic modifications. Innovative conclusions. Preliminary findings indicate that classical music tends to promote more coherent and aesthetically pleasing water crystallization patterns compared to the more chaotic structures formed under heavy metal and pop music. Corresponding experiments with DNA suggest that classical frequencies may enhance repair mechanisms, whereas heavy metal and pop could disrupt molecular integrity. These results propose a fascinating intersection between the aesthetic, vibrational qualities of music, and the intricate biological processes within living organisms. Implications for health and therapy. The research underscores the potential of using specific music genres as therapeutic tools to promote health and well-being. If classical music indeed supports DNA repair and structural integrity, it could be integrated into holistic health practices, enhancing current medical treatments and environmental strategies. Conversely, understanding the negative impacts of certain modern music genres could lead to better informed choices regarding personal and public health. Further research and considerations. While the findings are compelling, they prompt further investigation. Questions about the long-term effects of repeated exposure, the impact on different biological systems, and the potential for reversing negative influences arise. Additionally, cultural and individual variations in music perception and its biological effects need to be considered for a comprehensive understanding. Interdisciplinary synthesis and personalized research customization. Cross-disciplinary integration. This study extends beyond the realm of musicology and biology, incorporating insights from physics, psychology, and cultural studies. The physics of sound and vibration offer a fundamental understanding of how music frequencies interact with molecular structures. Psychological perspectives provide a lens to understand how perceived music influences emotional and physiological states, which in turn could affect DNA repair and health. Cultural studies illuminate the diverse interpretations and sensitivities to music across different societies, which might impact the effectiveness and reception of music-based therapies. Illustrative examples. To elucidate complex concepts, we draw on a range of examples from various disciplines. For instance, the use of classical music in medical settings as a form of therapy is juxtaposed with the cultural phenomenon of using high-tempo genres in fitness and entertainment, discussing the contrasting effects on the body and mind. Analogies from nature, such as the resonance phenomena observed in physical structures, help explain how musical vibrations might align with molecular frequencies in water and DNA. User-centric topics. The research is tailored to address the diverse interests and concerns of its audience. For instance, individuals interested in the therapeutic aspects of music can find detailed analyses on how different genres influence healing and well-being. At the same time, those curious about the scientific underpinnings can explore the detailed quantum and molecular biology discussions that explain the observed phenomena. Focused exploration, detailed inquiries into specific genres' effects, such as the distinct impact of subgenres within classical and modern music, are presented. This includes examining how variations in composition, such as the use of minor versus major keys or the incorporation of synthetic versus natural sounds, alter the effects on water and DNA. Users interested in a particular aspect of this research are encouraged to provide input to further refine and focus the study according to their interests. Ethical and philosophical depth. The paper delves into the ethical implications of using music as a therapeutic tool, discussing consent, accessibility, and the potential for misuse. Philosophically, it explores the notion of aesthetic beauty in music and its correlation with healthier molecular structures, pondering whether there is an intrinsic quality to harmony that resonates with the natural order of life. It also considers the ethical considerations of manipulating environmental and biological systems through sound. Creative exploration. We employ creative problem-solving strategies to hypothesize about the uncharted territories of music's influence on molecular structures. For instance, could there be a universal frequency or set of frequencies that universally promote health and well-being? What might be the implications for medical treatments, urban planning, or even interstellar communication? These speculative inquiries encourage thinking beyond traditional paradigms. Paradigm-challenging perspectives. The paper challenges existing paradigms by proposing that music is not merely a cultural and emotional experience, but also a potent environmental factor capable of influencing molecular structures and health. It calls into question long-held assumptions about the separation between art and science, suggesting a more integrated, holistic view of the natural world and human interaction with it. Philosophical insights. Philosophically, this study invites reflection on the nature of beauty, harmony, and health. It explores whether there is an objective basis to the healing properties of certain music types, or if these effects are entirely subjective and culturally constructed. The research also ponders the dualistic relationship between sound and silence, considering how the absence of sound impacts water structure and DNA integrity, thereby contributing to a broader understanding of vibrational influence in the natural world. Creativity and innovative problem solving. The paper employs creative methodologies to explore innovative solutions to health and environmental challenges. It speculates on future technologies that might harness the power of music and sound frequencies for medical treatments, urban design, and ecological restoration. The research also suggests developing new musical genres or compositions specifically designed to promote DNA repair and cellular health, encouraging collaboration between scientists, musicians, and therapists. Paradigm-challenging perspectives. Continuing to challenge traditional paradigms, the paper suggests that the influence of music on water and DNA could signify a broader principle of vibrational impact on matter and life. This perspective opens up new avenues for understanding and manipulating the physical world, with profound implications for medicine, technology, and environmental conservation. It advocates for a more holistic, integrated approach to science and art, where each informs and enhances the other. Theoretical plausible further research. Proposing areas for further research, including long-term studies on the effects of music exposure on human health, cross-cultural analyses to understand the universal versus culturally specific impacts of music, and experimental investigations into the potential of sound frequencies to repair environmental damage. It also suggests developing more sophisticated tools to measure and visualize the impact of sound on molecular structures, thereby deepening our understanding of this phenomenon. Theoretical, plausible, further research and practical applications for health and intelligence enhancement. Longitudinal studies on classical music and health. Future research should focus on longitudinal studies tracking individuals' health, well-being, and cognitive abilities over time with regular exposure to classical music. This would provide more concrete evidence of the long-term benefits and potential enhancements to mental and physical health. Comparative analysis of water and blood responses. A comparative study should be undertaken to analyze the patterns formed in water when exposed to classical music versus the molecular changes in human blood under similar conditions. This could provide a more direct understanding of how these patterns might translate to biological benefits. Neurological impact of classical music. Investigating the neurological changes and enhancements associated with listening to classical music can provide insights into how it improves cognitive functions, emotional well-being, and overall brain health. Cultural and individual variability in music perception. Further research is needed to understand how cultural backgrounds and individual differences affect the reception and impact of classical music on health and intelligence, ensuring that applications are inclusive and effective for diverse populations. Practical applications for health and intelligence enhancement. Incorporating classical music into daily routines. Encourage individuals to integrate classical music into their daily lives. This could be through listening sessions, attending live performances, or even playing an instrument. The goal is to create a consistent and immersive experience that promotes mental and physical well-being. Designing therapeutic programs. Healthcare providers and therapists should consider designing programs that use classical music as a therapeutic tool. These programs could be tailored to address specific health conditions, such as stress, anxiety, or cognitive decline, and could be incorporated into rehabilitation, meditation, and therapy sessions. Educational integration. Schools and educational institutions should integrate classical music into their curriculum to enhance learning environments. Studies suggest that exposure to complex musical compositions can improve concentration, memory, and learning capabilities. This integration could take the form of music classes, background music during study sessions, or special programs designed to pair classical music with learning activities. Public health initiatives. Governments and public health organizations could launch initiatives promoting the benefits of classical music. This could include funding for public performances, providing access to classical music libraries, and supporting research in this area. Public campaigns could raise awareness about how regular exposure to classical music can contribute to overall well-being and cognitive health. Personalized music therapy. Develop personalized music therapy sessions that align with an individual's preferences, health conditions, and therapeutic goals. By combining the soothing and complex patterns of classical music with a tailored approach, individuals can receive targeted benefits that enhance their mental state, well-being, and intelligence. Conclusion. Listening to classical music is more than an aesthetic experience. It's a potential enhancer of human health and intelligence. By forming beautiful and stable patterns in water, classical music suggests a corresponding potential to beneficially structure and influence the fluids within the human body, including blood. The proposed research and practical applications aim to harness this potential, offering pathways to improved well-being, mental state, and cognitive enhancement. Through continued exploration and integration of these practices, individuals and societies can unlock the profound benefits classical music offers, enhancing the human experience on multiple levels. Thanks for watching. Please like this video and subscribe to our YouTube channel for more free, interesting, original research. Check out the full research paper at Research Forum.